Hi, this is Mr. Bo from MrBoEnglish.com. This is yet another video in the Khan Academy Quadratic unit here, and we're in a vertex form lesson. We're going to do the last video in vertex form lesson, and it's going to be on word problems. I have a separate video on word problems and how to look at quadratic word problems, which is just above this one. So if you want to take a look at it before you watch this one, please do that. Stop now, go to the video above on this playlist, and then come back to this one after. All right, let's get started. I'll move my camera here. All right, so Ming throws a stone off a bridge into a river below. The stone's height in meters above the water, X seconds after Ming threw it, is modeled by. What is the maximum height the stone will reach? So if we're over here, I've got a little. Definitely don't want calligraphy. I've got a little bridge, and then we've got a lake, and we've got Ming up here, and Ming is going to throw a rock off, and that rock is going to land. And when it lands, what is the height? The height when it lands here is 0. We have another height, the initial height here, which is going to be our y-intercept. And we have the vertex, and the vertex tells us both the time and the height when it's at its maximum. And the question here is, what is the maximum height that the stone will reach? So we need to find, first of all, we need to find the time that it's the highest, and then we will find the top, right? Okay, so we've got a vertex form already. So this is actually a question about where the vertex is. What is the y for the vertex? And you'll remember the vertex form looks like y equals a times x minus x1 squared plus y1, where x1, y1 is the vertex. So if we already have it in this form, so we can easily find the vertex. Vertex is going to be at minus x1 or x minus 1, so the vertex is going to be at 1, and plus y1 over here, and plus 45 over here, so it's going to be at 45. So what is the maximum height the stone will reach? The answer is 45. Don't need a calculator for this one. What is the maximum height that the stone will reach? 45. Okay, move my stuff again. Okay. Let's take a look at the next one. We're a little slow today. What's happening? All right, I will reload here. Okay, so here's our second question. We're on question number 2. We can see what question we're on down here. The fish population in a certain part of the ocean, in thousands of fish, as a function of the water's temperature in degrees Celsius, is modeled by. So the temperature is our independent variable, and the fish population. So if the temperature is between some some range here. There we go. Some range here. You know, on the lower range. Yeah, here we go. On the lower range. Sorry, I'm mirrored. On the lower range, there won't be many fish surviving, and as we get towards the middle, we'll get more fish, and then we'll go down. So our parabola, our fish population will look like this, and then here's our x-axis. So at some points we're going to have like no fish living, and then at another point we're going to have the most fish population, the largest fish population. And so this is the equation, and the question is, what temperature will result in the maximum number of fish? And you'll remember from my word problems video, there's really only like four questions I'll ask, and one is, what is the y-intercept? And the other is, what is this zero, the second zero? And the third is, what is the x for the vertex? And the fourth is, what is the y for the vertex? So you can either ask, how, if it wants to know about the maximum, how many fish are the maximum, or what is the temperature for the maximum? And this one is asking us what temperature, so it wants x1. So let's see, let's remember vertex form, x minus x1 squared plus y1, and then we'll look over here, -2, so -2 is our a, and it opens down, that makes sense. X minus 9, 9, x1 is going to be 9 here, and y1 is going to be 200. So the question is, what time, what temperature? And what temperature is, what temperature? 9 degrees. 9 degrees Celsius, we get the most fish. Khan is not fast for me today, so apologies for that. Okay, here's our question number 3 on this problem. A hovercraft takes off from a platform. Its height in meters, x seconds after takeoff, is modeled by... So over here, here's my graph, and over here I have seconds, which we're calling x, and over here I have height, which we're calling h. All right, and so it takes off from a platform. So here's my platform, and it's going to take off, and it's going to come down some seconds later. So the question is, what is the height of the hovercraft at the time of takeoff? And again, we've only got 4 points, 4 questions they're really going to ask, because we've only got 4 really interesting points right here. Okay. We've got our highest value, and in here the time when it's the highest, when does it get back down to 0, and where does it start? So this is at the time of takeoff. This is asking us, where does it start? So it wants the y-intercept. And the height at the time of takeoff, height at the y-intercept, what do we know? We know that x is 0, and we want to know y. So how do we find that? We find h of 0. -3 times 0 minus 3 is -3 squared plus 108, and that's 9, -27, plus 108 is 81. So our height at the time of takeoff is 81 meters. Let me go through and double check that. Alright, so I've got 0 minus 3 is negative 3. Negative 3 squared is 9. Minus 3, negative 27. Okay. That's a lot of meters. That's a lot of meters. So, okay, Khan is deciding not to work at all unless I refresh today. So, all right, this is our last question. Okay, we actually have the same problem. I shouldn't have restarted here. Okay, so we've actually got exactly the same problem with the same formula. So here's our hovercraft taken off from a platform, and before we found out that it was 81. We could be interested in this how many seconds, or how high, or with the 0 when it lands. So what's the question? How many seconds after takeoff will the hovercraft land on the ground? So it wants to know, when does it land? What's the x value when it lands? And how do we find that? We find that by making a 0. So our formula is 0. Our height is 0. Negative 3 times x minus 3 squared. We don't know x, and we want to find x. We'll want to solve for x. Plus 108. Okay, so now I'm going to subtract 108. Whoops. 108 on both sides. This is like what we did when we did our find the square root lesson about 4 videos ago. Okay, whoops. Said 4 videos, I wrote 4. All right, I'm going to divide by negative 3. Divide by negative 3, and now I've got 36 equals x minus 3 squared. I'm going to take the square root, and I'm going to end up with 2. One is positive 6, and one is negative 6. Negative 6 squared is 36. Positive 6 squared is 36. So I'm going to add 3 to both sides. And I'm going to get negative 3. And I'm going to get 9. So negative 3 is this one back up over here. And that's not the one we want. We want to know when it lands on the ground. So that's the second one over here. And that one is going to be 9. All right, so that's how you do word problems for quadratics in vertex form. We'll have one more set of word problems. If you're having problems with word problems, if you are having problems with word problems, go back and watch the video above on the playlist, or if you're not on my playlist, else look for the quadratics playlist. And it will tell you how to look for these different points. Where do we start? How high do we get? When do we get the highest? Or where do we land? And that's really the only 4 things that they'll ask for. All right. If you have any more questions, please get a hold of us at MrBoEnglish.com. Mr. Bo English รับสอนนักเรียนตั้งแต่ป .3 ขึ้นไปทางอินเทอร์เน็ตในสไตล์ EP ครับผู้สนใจช่วยติดต่อครูแจงหรือไปเว็บไซต์ที่ www.mrboenglish.com